All right. We're going to do part of 5-5 today. 5-5 is the other four trig functions, graphing them, tangent, cotangent, secant, and cosecant, and they kind of come in pairs. So today we're going to do just tangent, cotangent, and then tomorrow we'll wrap up the section with secant and cosecant. You're going to see a lot of what we do as far as like the graphing goes. Like if you flip your paper over, it's going to be that key point method again. And we're going to use a lot of the same formulas that we've been using with sine and cosine. So a lot of this is not going to be new. The new part really is going to be these first two slides. Tangent and cotangent, the shapes are a little bit different, so their properties are a little bit different. So, and that means our key points are going to change a little bit as well that we're going to use when we transform them. So we're going to get all this filled out first. We're going to do the tangent one together, and then I'll let you guys with your groups try the cotangent one. Okay, so one period of the tangent graph is one little kind of squiggly S shape. That is one period of the graph, and then that's the shape that's repeating over and over again. We do have asymptotes. You can see they're labeled here with our dashed lines. So those are going to be undefined values in our domain. So let's start with period. What is the width of one shape in this graph? How long is it? Not pi over 2, a little bit bigger than that. It is pi units long. A good place to look would be between pi over 2 and 3 pi over 2. You can find the difference between those two values, and the difference is 1 pi. Okay, even or odd? So even is where we reflect it over the y-axis. Odd is where we flip it upside down. What do you think? This guy is odd. Domain, this is going to be the only time I'm going to allow you to write domain without interval notation, because if we used interval notation, there would be an infinite number of intervals. This is an interval, this is an interval, this is an interval, and it goes forever left and right. So what we're going to say for domain is we're going to use this symbol, all real numbers. It's a capital R with an extra bar on it, except our asymptotes. And we'll list the asymptotes in a minute. So we're just going to say all real numbers except for the undefined values at the asymptotes. What's the range? Negative infinity to positive infinity, all real numbers up and down forever. Okay, so the asymptotes. Asymptotes are anywhere we see a dashed line, and you can pick any of them as a starting place. So I could pick like pi over 2 as a starting place, or 3 pi over 2 as a starting place. And they occur every pi units because that's my period. So there's a special way we're going to write this. We're going to pick a asymptote. It doesn't matter which one as long as it's an asymptote somewhere on the graph. So I'm going to say pi over 2 is going to be my starting place. And then they repeat every pi units before and after that. So how we write that is we're going to say plus pi k, and k is an integer. So that means every pi units before and every pi units after pi over 2, we have another asymptote. So kind of the form that we're using there, if you want to make a note to self, is we've got an asymptote anywhere on the graph plus the period times k is the form that we're using when we write that. Okay, and that'll be the same when you get to the other functions as well. The zeros are going to be the same sort of situation. You're going to pick, remember 0 means x-intercept, so you're going to pick a x-intercept somewhere on the graph, like 0 here is a nice one to use. And then they occur every pi unit, so plus pi k. And because it's a 0 there, you actually don't have to have it. You could just say pi k would be the zeros. Okay, good? All right. Key points for this graph. The key points that we're going to use, and you could use any of them, any period of this, we're going to use the one in the middle there, okay? So we're going to start at an asymptote, and we're going to end at an asymptote. So here's what this is going to look like. My first key point is negative pi over 2. It's not a point on the graph. It's an asymptote, so we're going to write undefined, 0 with the line through it. And it ends at pi over 2 being undefined. Okay. In the middle, we go through the origin. We have a 0 at 0, 0. The other 2 points that we're going to use are going to be at -1 and +1. These are special values you can find on your unit circle. If I'm at pi over 4 on my unit circle, that's an easy tangent to calculate, right? Because we do y over x, but at pi over 4, it's rad 2 over 2 divided by rad 2 over 2, we get 1. It's a nice, pretty number. Same thing at negative pi over 4. If I go down pi over 4 units, it's pi over 2 divided by negative pi over 2, it's negative 1. So those can be really nice, pretty numbers. So we're going to use those. So my other key points are at negative pi over 4, I have a point at negative 1. And at positive pi over 4, I have a point at positive 1. And these are all from your unit circle. You just need to remember for tangent, you're going to start at the bottom. Negative pi over 2, negative 90 degrees, it's undefined. Then at negative pi over 4, it's negative 1. At 0, it's 0. At pi over 4, I'm up to 1. And at pi over 2, it's undefined. So it's the right half of your unit circle that we're using every 45 degrees. We get those. Okay? Questions? All right, so I want you guys to fill out the cotangent graph properties real quick. And for cotangent, the period that we use for our key points is the one that falls between 0 and pi there, just to the right of the y-axis. Okay, I'll give you a minute. Go ahead, work together, find the properties, list your key points. All right. Answers. As far as the asymptotes and zeros go, if you don't have 0 and pi over 2, it's not necessarily wrong. As long as this first number is an asymptote somewhere on the graph, you're okay. As long as the 0 is an x-intercept somewhere on the graph, you're okay. But both of them should say plus pi k at the end of them. Okay, key points at the bottom. If you look at the period that I circled there, it starts at 0 and it ends at pi. So when we're graphing cotangent, we're looking at the top half of our unit circle. And we're going every 45 degrees. So 0, I'm undefined. Pi over 4 is 1. Pi over 2 is 0 if I calculate the cotangent. 3 pi over 4 gives me negative 1, because it's negative in quadrant 2. And then at pi, I'm back to undefined. So tangent, you're on the right half of the circle. Cotangent, you're on the top half of the circle every 45 degrees. Okay. Questions on any of our properties up here? Okay, so now we're going to take those key points and we're going to do the same thing we were doing last week. So this is a good review of graphing our sine and cosine functions. Okay, so we're going to take our graph. We're going to name same formulas as before for scale changes and translations. We're going to name those rules. We're going to take the key points. We're going to transform them. We're going to make the picture, and then we'll name the properties at the end, either from the equation or from the picture, either one. Remember, if there's something in front of your x, it needs factored away from your x. This first one, that 2's already been factored out for us, so we don't have to worry about that. Okay, so rules for scale changes. Review from last week was reciprocal of b times x, a times y. What's the reciprocal of b in this equation? Just 1/2. X, and a is -3. Y. Bless you. My translations are x minus c, y plus d. Those are the rules. Same as sine and cosine. So x minus c will look like what? X minus pi over 4. Do we have a shift up or down on this one? No. So you can just say y or y plus 0 if you want. That's fine. What's the phase shift? Negative pi over 4. So it's opposite of c. Okay, key points. We are graphing a tangent function. Now, this is a little different than sine and cosine. The radian measures change based on which function you're graphing. Tangent, you need to remember, starts at negative pi over 2, ends at positive pi over 2. And it's every pi over 4 units. So I have a negative pi over 4, 0, pi over 4 in the middle. Whether it's tangent or cotangent, it's going to start and end at an undefined value, and there's going to be a 0 in the middle. Now you just have to remember which one of these is a positive one and which one is a negative one. It comes from your unit circle. I would look at pi over 4. If pi over 4 is my tangent, positive 1 or negative 1? It's positive 1. Negative pi over 4, it's going to be negative 1. It's going to be the opposite. You've got your key points. All right, now we're going to apply our rules. So I need to do 1/2 times my x's and negative 3 times my y's. 1/2 times my x's are going to give me negative pi over 4, negative pi over 8, 0, pi over 8, pi over 4. If something is undefined, it will remain undefined. There's nothing that I can add, subtract, multiply, divide by it to change that. So negative 3 times an undefined value is still undefined. Negative 3 times negative 1 is 3. Then I have 0, negative 3, and my last value is undefined. Then we do our translations. Our x's, we need to subtract pi over 4. Our y's are actually just going to stay the same here. Negative pi over 4 minus pi over 4. So think of it like negative 1/4 minus a 4th. What does that give you? If you need to write it in the margin, do the math with common denominators, you can do that. Negative pi over 4 minus pi over 4. What does it give me? Negative 2 pi over 4, which reduces to negative pi over 2. That's it. It's undefined still. Okay? Negative pi over 8 minus pi over 4. Again, if you need to write it out, do that. What's the common denominator? 8. So you can think of pi over 4 as 2/8. So I have negative 1/8 minus 2/8, which gives me negative 3/8. 0 minus pi over 4 is negative pi over 4. If I have positive pi over 8 minus pi over 4, I can think of it like positive pi over 8 minus 2 pi over 8. It gives me negative 1 pi over 8. And then pi over 4 minus pi over 4 gives me 0. Y values stay the same. 3, 0, negative 3, undefined. Okay, so all of that math there, that's the same as our sine and cosine functions. Nothing's changing. Graphing this. Negative pi over 2, we're going to make an asymptote. Vertical dashed line there. 0, we have an asymptote, so that's going to be on the y-axis. In the middle of those asymptotes should always be a 0, so negative pi over 4. I'm on the axes. And then between the 0 and the asymptote is where you're going to have points. One's going to be above the axis, one's going to be below the axis. Negative pi over 8, I'm at negative 3, and negative 3 pi over 8, I'm at positive 3. And then connect those 3 points. It's almost going to look like the graph of a cubic function, that similar shape there. And that's our graph. Okay, properties. What's the period? What's the width of that one period I graphed? It's pi over 2. If you want to calculate this one from the equation for tangent or cotangent, the formula is slightly different. It's pi over b instead of 2 pi over b. That's because the original period was pi for tangent and cotangent. When we talked about sine and cosine, the original period was 2 pi. So you can use pi over b instead. Domain, we know, is always going to be the same. It's going to be all real numbers except our asymptotes. Range will always be the same. It is all real numbers, negative infinity to positive infinity. Okay. Asymptotes and zeros, you can use your key points that you've got here. So asymptote, pick either asymptote. I'm going to pick 0 because that's a nice, pretty number. And then remember, it's always plus the period times k. We already named the period. It was pi over 2. K, and then when you introduce k into a problem, you need to say what it is. So I'm just going to put a little note at the bottom. K is an integer. You only have to do that once, but if you add something new, you got to say what it is. And then 0, same thing. We're just going to pick where we have an x-intercept, so you can use your key points. Negative pi over 4 is where we graphed an x-intercept at. Negative pi over 4 plus the period times k. plus pi over 2 times k. All right. The last problem of the day is yours to try. It is a cotangent graph. So you can use this one as an example. The only thing that's going to change are those key points, and you can use what you've got written on the previous side if you need a hint for those, okay? I'll give you a few minutes. Try with your partner or group or on your own if you want that cotangent graph, and then we'll be done. All right. Let's take a look. You got a pretty wide one this time. So this one had a horizontal stretch by 3, a reflection over the x-axis, and a vertical shrink by a half. So it got a little shorter, a little wider. It also went to the left pi units. That was our phase shift. All right, so I've got the math set up there for you. Double check your properties on the side there. Again, you can do pi divided by b. B was 1/3, so pi divided by 1/3 gives you that 3 there, or you can see it in the width there. It's 3 units long. Remember the first part of the asymptote and the zero, it doesn't have to be those exact numbers, as long as you picked a asymptote. So if you use like 2 pi here, that would be correct. A 0 in the graph, we really only had 1 0 there, but if you had one from another period, you could use that. Make sure on your paper you have k as an integer. It's going to be worth a point. Use that, okay? What questions do you have on this? Graphing tangent, cotangent. Naming their properties. Okay. Tomorrow we'll do the last 2 functions, and you're going to see they're going to be really similar to sine and cosine. So that'll wrap up all of our graphs for us. I want to show you guys real quick in Polaris. So on tomorrow we're going to finish up 5-5. On Wednesday, you guys are going to be working on like a quiz review that'll have solutions posted for you to get ready for your quiz on Thursday, if we're here on Thursday. The quiz on Thursday will be open notes, okay? So like the quiz review, the handouts we've been using, notes, you guys can use all of that, and it's going to be over all of our graphing stuff, sine, cosine, tangent, cotangent, secant, cosecant. Because we're going to be working in groups on Wednesday, I'm going to take that day to meet with you individually about your course registrations for next year, because all your teachers need to get that in by the end of this week. I need to put in whatever you want to do. So I wanted to show you in Polaris where this is located at, just so you can kind of start thinking about it before we sit down together on Wednesday. So there's a link that says course options for next year. We have a lot of options after this class. This is just a Google Doc you can take a look through. I went ahead and listed every other course that you could potentially take after this one. And for each of them, I've got the course name and number that you would put on your little sheet when you give it to your counselor. And then I gave you kind of a description. Is it a year long? Is it a semester long? Is it AP? Is it CCP? If it's CCP, how many credits is it? Why would you take that course? That sort of thing. I would just say in general, and this is like a 3-page long document. There's a lot of options here. If you don't know what you want to take next year, number one, you can ask me and I will help you. But if you know what you are going to major in college, or you have like a general idea, like I think I want to go into pre-med, or I think I want to go into engineering, but even if you don't know like what exact route you're going yet, it is helpful to look up a degree requirement sheet for that university. And if you don't know what university you want to go to yet, just look up like Kent State business degree requirements. Google that, and it will list out all of the courses you need to earn that bachelor's degree. Specifically look at the math classes. If you need calculus, it will be listed. Some of you don't need calculus. Don't take calculus unless A, you love it, or B, you need to take it for your degree. If you need statistics, take statistics, because the point of all of these classes, right, is less that you have to take when you get to college. So whatever you sign up for, you should either A, be passionate about it, or B, it should be benefiting you in the long run when you go to school next year. Does that make sense? Okay? All right. So take a look at that document sometime before we chat on Wednesday, even if you don't have like a firm idea on Wednesday. I can kind of help you through it, and I can always recommend you for more than one. Like I have students that this year are taking calculus and statistics at the same time. That's an option if you know you're going to be like heavy math major or something like that. I can recommend you for more than one class. All right. Okay, so that's all I got for you for today.